You are right. God bless you. He said that homeostasis. Did you hear what he said? Did you hear what he said? I say it again.
It simply means the maintenance of body in the lack environment.
Homeostasis is the maintenance of the internal walls. Is it also? Are you there? When we talk about homeostasis, we are talking about the maintenance of the what? I introduced this term, right? To have a what? Better. In the 19th what? Century. He was the one that first of all introduced what? He told us about a situation whereby multicellular organisms, including humans, right? The way the system is the internal environment is what is good or put on that was checked. And that system is called homeostasis. It is called what? Homeostasis. But the word was coined by somebody, an Harvard professor, right? An Harvard professor called Cannon, B. Cannon. He was the first person to coin this word, homeostasis. Homeostasis. Right? And the system where the body controls what? The internal what? Environment. Right? We call it internal what? Milieu. You know what we call internal what? Milieu. It is called what? Internal what? Environment. Now, what do we mean by homeo? Homeo and stasis. What is homeo and what is stasis? Homeo simply means same. Are you there? Homeo means what? Same. What about stasis? Stasis means what? Standing still. What did I say? Standing still. So homeostasis means the situation whereby the certain parameters of the body are what? Are standing what? The body are the same. Right? It is a state of dynamic equilibrium. It is a state of what? Dynamic what? Equilibrium. Balance. You know what equilibrium means? It is a state of what? Balance. Right? Where certain parameters in the body are what? Balanced. You know, when we talk about physiology, physiology encompasses cells, tissues, and what? Organs. Are you there? And the cells, the tissues, and organs have to be what? Have to be what? The cells have to be what? Properly what? Their function has to be regulated. Right? Their function has to be what? Regulated. In order so that there will be no problem. Is it not so? The tissues also have to what? They have to function optimally so that there will be no what? Problem. The organs also have to function optimally so that there will be no what? Problem. Then we have what we call organ systems. Are you there? The organ systems have to be what? Properly what? Regulated for them to be what? Balanced. Are you there? Are you there? Any deviation from what is normal, or what we call the set point, any deviation from the set point will bring about a problem. So the body is always, the body has a certain mechanism, right, to keep certain parameters in check. Do you understand? It has what? Certain mechanisms to keep what? Body what? Parameters what? In check. Are you there? Are you there? All right. Remember, he said he's actually baked in fluid. You see also, right? He said he's what? Baked in what? In fluid. And without that fluid, the cell cannot what? Survive or function. It's just like a unicellular organism. You know, we have unicellular organisms and multicellular what? Organisms. Now, take for instance, a unicellular organism that is in what? The ocean. Are you there? Or in the water body. Right? Now, without that water body, the unicellular organism cannot function. Is it also? Are you there? The same thing is applicable to multicellular what? Organisms. Without fluid, they cannot what? Function. Are you there? Are you there? The fluid must have the right nutrients, the right oxygen, and whatever to ensure the survival of what? The cell. Is it also? Are you there? Cellular what? Extracellular what? Fluid. And of course, the extracellular fluid consists of what? Who can tell me? Say it, say it. It consists of blood, right? Interstitial what? Fluid. Are you there? So your cell is bathed in what? ECF. Which consists of blood and what? Inter what? Stitial what? Fluid. Are you there? Are you there? I said your cell is bathed in what? Extracellular what? Fluid. That is made up of what? Blood and interstitial what? Fluid. And they must have the right nutrients, right? The right nutrients, and nutrients must be and the right electrolytes, the right for your cell to what? Function. Are you there? Are you there? Now, let's say this is your cell. Let's say this is your cell, right? And your cell is driven by certain biochemical processes. Is it also? Are you there? Certain biochemical processes, right? Drives the cell. True of us. Are you there? And that is to say that substance A will usually be converted to what? Substance what? B in the cell. Is it also? Are you there? Are you there? Now, this process must be driven by certain biochemical process. Take for instance, an enzyme has to drive this process. Is it also? Are you there? An enzyme is a biochemical, right? Are you there? Now, let's say an enzyme will drive this process. Is it also? Now, the cell cannot function if the pH of the body is not in the right proportion. True of us. Are you there? And mind you, the pH of the body is what? 7 point what? 7.4. So any deviation from this value will cause a problem. If this value comes down below this, we are going towards acidosis. Are you there? Are you there? We are going towards what? Acidosis. Right? And acidosis is not actually good for the cell. Are you there? It's not good for the enzyme. It will denature what? The enzyme. And when once the enzyme is denatured, this biochemical process will not be driven, and then the cell will run into problem. True of us. Are you there? If the pH goes above this value, right, we are going towards what is called alkalosis. Right? And alkalosis is also not good for the what? Cell. Because it will affect the enzyme. And when once the enzyme is affected, it will affect what? This process, this biochemical what? Process. And when once the biochemical process is affected, it will affect the what? The physiology, the entire physiology of the cell. Are you there? Because biochemistry and physiology are brothers and what? Sisters. If biochemistry is affected, physiology will be what? Affected. Are you there? Are you there? Right. So now, so the cell, the pH of the cell has to be in the right what? Proportion. Right? For the cell to what? Function. Is that clear? Is that clear? Yes. Also, the temperature of this cell or the environment has to be what? Optimal. Are you there? Yes. The temperature has to be what? Optimal for the cell to what? Function. Is it also? Yes. The normal temperature of an individual is what? What? 37 point what? 5. Temperature 37 point what? 5 degree what? Celsius. Is it also? Right? So now if there is an increase in temperature, what will happen to the cell? To this enzyme? It will denature the enzyme, and when once the enzyme is denatured, it will affect this biological what? Process. If there is a decrease in temperature below this value, what will happen? It will also affect what? The enzyme. The enzyme will not what? Be able to what? Function, and it will affect the biochemical process, and as well affect the what? Physiological process of what? The cell. True or false? Is that clear? Yes. Are you there? Also, apart from the fact that we need the right pH and the right temperature, we also need the right amount of nutrients for this cell to function. Are you there? We need the right amount of what? Nutrients for the cell to what? Function. You get it? Are you there? A good example is that we need the right amount of what? Glucose. Are you there? To drive the biochemical process. Are you there? But for it to produce ATP, are you there? But for it to produce ATP, it needs the right amount of what? Glucose. Are you there? It needs the right amount of what? Glucose. Right? The glucose should not be too high, and the glucose should not be too what? Low. If the glucose is too low, we are going towards what? Hypo what? Glycemia. If the glucose is too high, we are tilting towards what? Hyper what? Glycemia. And it is not good for the what? Cell. Are you there? It is not good for the physiology of the cell. So for the cell to function optimally, the glucose level has to be what? Within a set point. It must be what? Optimal. Are you there? Also, for this cell to produce energy, it does not only need nutrients, it does not only need glucose, but it also needs oxygen. True or false? It also needs what? The right amount of what? Oxygen to drive this process. Are you there? If the right amount of oxygen is not provided, then there will be a problem. The cell will not be able to produce the required amount of energy, right, to drive this process. Are you there? Right? If the oxygen level is too high, it will also cause a problem. Is it also? Right? All right. Also, for us to get the right amount of oxygen, right, we also need blood supply. Do you understand? We also need what? Blood supply. The blood has to have the right amount of what? RBCs, red blood cells. The red blood cells have to have the right amount of what? Hemoglobin. Right? Yes. And of course, you know the hemoglobins are responsible for transporting what? Oxygen. Is it also? So the right amount of hemoglobin must be present within the red cells. We must have the right amount of what? The right amount of what? RBCs, erythrocytes. Are you there? If the number of erythrocytes decreases, we are going towards what? Anemia. And anemia is not good for the what? Cell. Are you there? Anemia is not good for the what? Cell. If the number of red blood cells increases, we are going towards what? Polycythemia. Are you there? We are going towards what? Polycythemia. And especially if the polycythemia is pathologic, then it is not good for the what? Cell. So the right amount of red blood cells, the right amount of blood must be what? The right amount of red blood cells, erythrocytes, must be what? Provided. Are you there? And the right amount of blood pressure must also be provided. Because if the blood pressure, right, Hello, are you listening?
Yes, sir.
Are you following? If the blood pressure is not normal, right? If the blood pressure is not normal, it will affect the physiology of the cell. Are you there? Do you understand? It will affect perfusion. You know what to call perfusion? You don't know what is called perfusion? The blood, right, has to provide adequate amount of oxygen and nutrients for the cell. Are you there? That's perfusion. Are you there? The ability of what? The blood to provide the right amount of nutrients and what? And oxygen to the cell. Are you there? That's what we call what? Perfusion. Are you there? And then if the blood pressure decreases, what will happen? Perfusion will what? Decrease. It will affect perfusion. Are you there? Are you there? And also, the blood pressure is not supposed to what? Go above the normal what? Range. You get it? Are you there? Alright. Now, apart from this, we also need the right amount of other substances like amino acids, right? Fats in the form of what? Lipid. Are you there? Lipid. We also need what? Vitamins. Right? Are you there? We also need what? Vitamins, and then we also need minerals, the right amount of minerals. That has to be what? Provided. Are you there? Are you there? Now, so many biological processes, right, in the cell is driven by what? Hormones. You know what we call hormones? Hormones are what? What are hormones? What are hormones? Tell me now. They are chemical what? Okay.
That transmit some impulses.
Who can tell me what a hormone is? Who can tell me? It's a hormone. I'm sure you did biology. Huh? You did do biology? Tell me now. Don't fall my hand. What is a hormone? If you don't tell me, I will not continue. You must tell me. What is it? You know, hormones are chemical messengers. Is it also? That are produced by what? Endocrine what glands. Endocrine glands are glands that are what? Ductless. They don't have ducts. Are you there? They produce these substances somewhere. The change is elsewhere. And they are carried by what? The blood. So the right amount of hormones. Right? The right amount of hormones have to be what? Also what? Provided or present in optimal what? Amount for the section. Right? Are you there? Not only that, the right amount of water. The right amount of water also has to be what? Present. Right? If we have less amount of water, what will happen? The cell will be what? Dehydrated. Is it not so? If we have plenty water, excess amount of water, then there will be water what? Toxicity. Right? Are you there? Which is not good for the what? For the cell. Are you there? There is also the right amount of electrolytes. The right amount of what? Electrolytes. Has to be what? Present. Electrolytes like what? Sodium. Right? Potassium chloride. Right? The right amount of what? Electrolytes has to be what? Present for the cell to what? Function. Are you there? You know, for example now, take excitable tissues for, as an example. A good example is muscle and nerve. Right? Muscle and what? Neuron. Right? Now, if the amount of electrolytes is not optimal, right? Are you there?
Yes, sir.
If the amount of electrolyte is not optimal, then it will be very difficult for the neuron or the muscle to do what? To generate what? Impulses. Right? Are you there? If the amount of what? Electrolytes is not optimal, it will be difficult for muscle cells, which are what? Myocytes, and what? Nerve cells, which are what? Neurons. It will be difficult for them to produce what? Electrical what? Impulses. So the right amount of what? Electrolyte has to be what? Also what? Present. Are you there? Now the next thing we shall talk about. You are making noise. Don't make noise.
Stop making noise.
The next thing we shall talk about is what? The component of homeostasis. What are the components of homeostasis? The first thing we shall talk about is what? Yeah, you are right. Detectors. Oh, no, sorry, stimulus. Right there, stimulus or deviation. Are you there? The second component is what? Detectors. The third component what? What? Control system. Are you there? If you don't call it control system, you call it integrating system. Are you there? Then the next thing we shall talk about is what? The next one is what? The effectors. Are you there? Are you there? Now, when there is a deviation in the physiology of the body, right? When there's a deviation, that deviation, in other words, is called what? A stimulus. Are you there? That deviation is a stimulus. True or false? Now, that stimulus, you know what we call stimulus, right? Are you there? Now, the stimulus will have to be what? Sensed. Are you there? They'll be what? Sensed or detected by what? Receptors. Right? Or what we call detectors. Are you there? There are detectors in the body that will what? Pick the slightest deviation in the body. Or the slightest what? Stimulus in the environment. Are you there? Now, when they pick this stimulus, what do they do? The detectors cannot actually bring a change to the deviation. They cannot correct the deviation, right? So, but what they do is that the detectors will send what? Information. Are you there? They will send what? Information to the what? The control what system, which is also known as what? The integrating what system. Are you there? Now, the control system will pick this information, right? And then we send an information to what? The effectors. To do what? To correct the what? The deviation. Are you there? Okay, let's do it this way. Now, first of all, there's a deviation here, or a stimulus, right? Are you there? The stimulus of deviation will be what? Detected. By what? Detectors. Right? Are you there? And then the detectors will send information to where? To the control what? System. If we don't call it control system, we call it what? The integrating system, which will process the information, right? It will process the information and send what? An information to what? The effectors, or what we call effector organs, right? To the effectors. And what will the effector do? The effector will connect what? This what will react to what? The stimulus. Are you there? Are you there? So you should know that the detectors cannot actually correct the what? The deviation. These detectors cannot react to what? The stimulus. What they do is that they send information, they send impulse, right? Information or impulses to what? The control system. Are you there? And then the control system will process this information and then send the information to what? The effectors that will now react to what? The deviation and normalize the what? Situation and bring it to optimal what? Level. Are you there? Do you understand? Do you understand it? Yes. All right. Now, let's talk about the mechanism. The mechanism of homeostasis. You are making noise. Mechanism of what? Homeostasis. Are you there? Now, when we talk about the mechanism of homeostasis, two things come to our mind. Number one is what we call the feed-forward mechanism. What did I say? The feed-forward mechanism. And the next one is called what? The feedback mechanism. Right? So we have the feed-forward mechanism, and then we have the what? The feedback mechanism. There's a difference between the two. Right? Are you there? There's a difference between what? These two. Feed-forward mechanism and feedback mechanism. I said feed-forward mechanism and feedback mechanism. They are not the same things. You said they are the same thing?
No.
They are not the same thing. Feed forward and feed backward mechanism. So what is the difference? Who can tell me? What's the difference? What's the difference? There's a market going on there. There's a market. I want to buy pepper. Please go and buy the pepper from that place. Who is making noise here? So what's the difference between feed forward mechanism and feedback mechanism? Who can tell me? Oh yeah, go on.
The feed forward mechanism is making the help enhancing or pushing forward the process.
Now listen. The difference between these two is that, first of all, let's say there's a stimulus, right? Let's say there's a stimulus. Feed forward mechanism occur before the stimulus. Are you there? Feedback mechanism occur after the stimulus. You got it? Feed forward mechanism occur what? Before the stimulus. Feedback mechanism occur what? After the what? Stimulus. So feedback mechanism reacts to the stimulus. Are you there? Feedback mechanism react to what? The stimulus. Feed forward mechanism occur before the stimulus. Are you there? We call feed forward mechanism an anticipatory what? Mechanism. Are you there? It is referred to as what? An anticipatory what? Mechanism. A mechanism that occurs before the stimulus ever takes place. Are you there? Are you there? Even before the stimulus will take place, right? Feed-forward mechanism is a mechanism that occurs before the stimulus. I will give you an example. For instance, if you want to engage in an exercise, are you there? You want to engage in what? An exercise. Can you hear me? You want to engage in what? Exercise. You discover that even before you start the exercise, your heart rate will increase. Is it also? Before you begin the exercise, your heart rate will what? Increase. Your heart rate will increase. And then why does the heart rate increase? Who can tell me? Right? Why does the heart rate increase before the exercise? It increases so that it can provide a lot of what? Blood, right? Nutrients and oxygen to what? To the muscles before the action of what take place. Are you there? Are you there? Before you start the exercise, your heart rate will what? Increase. Why? So that it will provide enough blood, pump enough blood to what? To the muscles. Yes. Yes. Okay, take for instance now. You want to cheat in an exam. You want to cheat in an exam. Your heart will start beating faster. Is it also? Right? Your heart will start beating what? Faster. Is it also? As a feed-forward what? Mechanism. You want to do exercise. Your heart will start beating what? Fast. In anticipation of what? The exercise. Are you there? Another example is during feeding. The sight of food, right? The sight of food can make you to what? Salivate. Are you there? The sight of food can make you to what? Salivate. So even before you eat the food or put the food in your mouth, already you have started what? Salivating. Are you there? And not only that, the sight of the food, the smell of the food, the thought of the food alone can make you to start producing gastric what? Juice in your stomach. Are you there? We call that the cephalic phase, right, of gastric secretion. Are you there? It is called the cephalic phase of gastric what? Secretion. The thought of food, the sight of food, the smell of food can make you to what? Produce what? Gastric what? Acid. So that before the food will get to the stomach, already you have enough, the right amount of what? Gastric. So that's the thing of what? The feed-forward what? Mechanism. Do you get it? Are you there? Now the next one we shall talk about is the feedback what? Mechanism. Feedback what? Mechanism.
Staff solution.
The next one is what? Feedback what? Mechanism. Now when we talk about feedback mechanism, what are we talking about? We are talking about the mechanism that reacts to what? A change. Are you there? Are you there? A mechanism that what? Reacts to what? A change or a stimulus. Don't make noise there. Don't make noise. We are talking about a stimulus that what? Reacts to what? A change or what? A deviation. Are you there? Are you there? Now in feedback mechanism, we have what we call inputs and outputs. Are you there? Usually the outputs, right? Right? In feedback mechanism, a proportion, right? In feedback mechanism, a proportion of the output usually react to what? The input. Do you get it? Are you there? I said during feedback mechanism, a proportion of the output, you know, the feedback mechanism will have input. The input is coming from the stimulus, right? The input is coming from what? The stimulus. And the output what? The response that is given by the effector. Are you there? Now, a proportion of the what? Of the output influences the what? The input. The feedback what? Mechanism. And we have two types. How many types? We have what? Two types of what? Feedback what? Mechanism. The first one is called what?
Input.
We call it negative feedback mechanism and positive what? Feedback what? Mechanism. So number one is negative feedback mechanism, and number two is what? Positive what? Feedback mechanism. Do you understand? Negative feedback and positive feedback. I will explain the two. Are you there? Okay. What is negative feedback mechanism? Who can tell me? Negative feedback. Yeah? Now, when there is a change, right, in the body physiology, right, what negative feedback does, right, is to what? To arrest that change. Are you there? If there's a change in body physiology, negative feedback mechanism counteracts that change. Are you there? It changes the direction of what? Of the deviation or the stimulus. Are you there? Negative feedback mechanism changes the direction of what? Of the deviation or of the what? Of the stimulus. If there's a change, negative feedback mechanism counteracts what? The change. I will give you several examples. Are you there? I will give you several examples. Now, let me draw a diagram. Are you there? Now, let's say this is an event that is occurring, right?
Yes, sir.
This is an event that is occurring, right? You can see that this event is going up and it's coming down. It's going up and it's coming what? Down, right? And then this event has these particular activities, right? Has a range. Or let's say this is a parameter. This parameter, right, is going up and going down, fluctuating, right? Going up and going down. And it has a range, right? And this, let's say this is the range. Are you there? And then there should be a set point. Are you there? The optimal what point or the average what level of this parameter. And that average level is this. Are you there? So this is what? Set point. This is the normal what? Level. For instance, pH. Let's say this is 7.4. This is normal. Right? Now if it goes up, it has become a problem. If it comes down, if it goes up, there's a problem. If it comes down, right? Yes. There is a what? Problem. A problem. It has to be here. Do you understand? A slight deviation can affect the what? The physiology of the body. Is it also?
Yes, sir.
Are you there? So this is a typical example of negative feedback what loop. Right? It goes up and what goes down. Right. Now, in negative feedback mechanism, when a parameter goes up, right, the negative feedback mechanism is supposed to bring it down to what? The set point. Are you there? The negative feedback mechanism is supposed to what? Bring it down to what? The set what? Point. If it goes down beyond this level, negative feedback mechanism is supposed to what? Bring it what? Back to what? The set point. That's what we call what? Negative feedback mechanism. You don't understand it? understand? All right. I said negative mechanism. What? There's a change. Negative feedback mechanism can what direction? Are you there? For instance, now let's say this is pH, right? And this pH has what? A set point. This is set point, right? Thank you. The equilibrium, right? This deviation, right? If there's an increase, what negative feedback mechanism do is to what? Bring it down to what? Normal. If there's a decrease, right? What it does is to what? Bring it back to what? Normal. Are you there? Are you there? Now, a typical example, I will give you several examples. Let me give you several examples. A typical example is blood pressure. Blood what? Pressure. Number one example is blood what? Pressure. Now, when there's an increase, right? When there's an increase in blood pressure, you know, our blood pressure is supposed to be what? The normal level is 120 what?
By 80.
Right. So if blood pressure goes above this value, let's say it becomes 150 milliliter mercury. You know, there's a problem here. Are you there? Now, this increase, right, is the stimulus. Is it also?
Yes.
That's the stimulus, that's the deviation. True of us. The increase in what? The deviation. Now, we have what we call, are you there? We have what we call what? Detectors or receptors, which you have rightly said, right? Now, the detector that detects an increase or a decrease in blood pressure in the body is called what? The baroreceptors. Are you there? We call them the what? The baroreceptors. Where are they located? They are located in what? The carotid body and the what? Aortic what? Body. Are you there? Do you know they are located in the carotid body and aortic what? Body. Right? I'll explain. Right? Now, if you look at, you know what we call the common carotid artery? The common carotid what? Artery, right? Now, if you look at the common carotid artery, at a point, let's say this is the arch of the aorta, right? The common carotid artery emanates from what? The arch of the aorta, right? At the point, it bifurcates into two, right? Forming what? The internal what? Carotid artery and the external what? Carotid artery. At that point of bifurcation, there is a bulge. It bulges a little bit, right? Are you there? And then there are several receptors that are located. There are several receptors that are located here. These receptors, right, are called what? Baro what? Receptors. Are you there? What do they do? When there's an increase in blood pressure, these receptors will be stimulated. Are you there? And they will pick the signal. Also, in the arc of this is the aortic arch, right? There are also what? Receptors in the arch. Are you there? Thank you. These receptors are also called what? Baro what? Receptors. Are you there? So when there's an increase in blood pressure, these receptors will be what? Stimulated. When they are stimulated, what happens? They will send a barrage of information to the brain. Are you there? They send a barrage of information to what? To the brain. Particularly to the what? To the medulla oblongata. The medulla of the brain. Are you there? Are you there? Particularly to where? To the what? Medulla what? Oblongata. Are you there? Now, the medulla is known as the control center or the control system or the integrating what system. So it picks this information, it receives the information, and then processes this information and sends an information to where? To the heart. Are you there? It sends an information to what? To the heart. So the heart is known as what? The effector. Right? So what does it do to the heart? What does the information do to the heart? The information stimulates the heart to increase what? The heart rate. No, sorry, to decrease the what? The heart rate. When the heart rate is decreased, what will happen to the blood pressure? The blood pressure will come down to normal. Is it not so?
Yes.
Are you there? The blood pressure will come down to what? Normal. Right? Not only that, it will also send information to the blood vessels. Right? It will what? Dilate the blood what? Vessels. When the blood vessels are dilated, what will happen? It will also crash the what? The blood what? Pressure. Are you there?
Yes.
Now, when there is a decrease, right? When there is a decrease in blood pressure, are you listening? Yes. When there is a decrease in blood pressure, what will happen? Let's say the blood pressure comes down below 120 to, let's say, what, 90 millimeters, right? The baroreceptors will also what? Be stimulated. When the baroreceptors are stimulated, what will happen? To send information to where? To the medulla. The medulla will send information to the heart. To do what? To increase the heart rate. It will also send information to what? The blood vessels. To do what? To constrict what? The blood vessels. It will bring about vascular what? Constriction. When there is vasoconstriction will bring about what? Increase in what? Blood pressure. Do you get that? Do you understand that? That's a typical example of what? Negative feedback what? Mechanism. I will give you another example. Should I give you another example? Another example is during, okay, let's say, okay. Now, when there is an increase, right? When there is an increase in tyrosine level, you know tyrosine? Tyrosine is what? A hormone.
Yes.
That is produced by what?
The thyroid.
The thyroid what?
Gland.
Are you there?
Yes.
And it affects body what? Metabolism. Is it not so?
Yes.
It affects what? Body what? Metabolism. It either increases or decreases body metabolism depending on the level. Do you understand? Now, when the level of tyrosine increases, right? An information will be sent to where? Not to the medulla. It will be sent to the what? To the hypothalamus. Are you there? And information will be sent to where? To the hypothalamus. Right? Why? Because, no, sorry, it will be sent to the pituitary. Are you there? To the pituitary what? Gland. Particularly the anterior what? Pituitary. Are you there? Because the anterior pituitary is responsible for producing a hormone that is called what? Thyroid stimulating what? Hormone, TSH. Are you there? Are you there? Thyroid what? Stimulating what? Hormone. Right. So when the level of thyroid increases, the information will be sent to what? To the anterior what? Pituitary to stop the release of TSH into the bloodstream. Are you there? Where? It goes to the what? Thyroid gland. It stimulates the thyroid gland to produce what? Tyrosine. Do you understand? Alright. Another example is when there is hello? Another example is when there is decrease. When there is decrease in what they call it? In water content of the body. Are you there? There's the water content in the body. Decreases. What will happen? If the water content in the body decreases, what will happen? Two things will happen. The first thing is that, right? The first thing is that the decrease will send information to the brain, the hypothalamus, right? It will stimulate the test centers, right? It will stimulate the test centers in the what? The hypothalamus. When the test centers are stimulated, what will happen? It will make the individual to start drinking what? Water. Is it also?
Yes.
The individual what? Begin to drink what? Water, which will restore the water what? Content. Is it also?
Yes.
Are you there? Also, when the water content is decreased, right? Are you there? Information, right, will be sent to where? Look at that.
The brain.
Information will be sent to where?
Hypothalamus.
To where?
Hypothalamus.
Not the hypothalamus, to the pituitary gland. Are you there?
Yes.
But this time around, the posterior what?
Pituitary.
It will stimulate the posterior pituitary to release what we call ATH. Anti-diuretic what? Hormone. Are you there? When ATH is stimulated, it goes down to what? To the kidney. And stimulates what? The distal convoluted tubule. When the distal convoluted tubule is and the collecting ducts are stimulated, right? In fact, it goes there to stimulate a receptor called the V2 receptors. Are you there? When these receptors are stimulated, it brings about what? The reabsorption of what? Water. And when water is reabsorbed by the kidney, what will happen? It will restore the what? The water level, the water content of the body. Is it also?
Yes.
Are you there? So if there is a decrease, then the reverse will be the what? Case. Do you understand? Do you understand? All right. Yes. The decrease is what? The first one is that it will stimulate the taste centers.
Yes.
The taste centers are located in what? The hypothalamus. Are you there? When the taste centers are stimulated, testing. Are you there? It will make the individual do what? Testing, and the individual will what? Crave for water, drink water, and then when the individual drinks water, what will happen? The water content will be what? Restored. Right? Lastly, I will talk about temperature what? Regulation. Right? Temperature regulation. When I talk about that one, I move to positive what? Feedback. Do we still have time?
No.
Do you have another class?
Yes, sir.
Which class? Yeah.
Anatomy.
Let me finish this topic.
Okay,
I'm
sir.
almost done.
Okay, sir.
Sorry.
Don't give yourself
Okay. Hello.
The second one you said it will stimulate the posterior gland and then
It will stimulate the posterior pituitary. Posterior pituitary produces two hormones. What are the hormones? ATH and what? Oxytocin. ATH and what? Oxytocin. But then, the hormone that is implicated here is ATH, which is anti-diuretic hormone. When anti-diuretic hormone is produced, it goes to where? To the kidney and stimulates what? The distal convoluted tubule and the what? Collecting ducts. These ducts are always impermeable to water. Are you there? They are always what? Impermeable to what? Water. They don't allow water to pass through and go back to the what? System. Are you there? When water gets to the what? The collecting ducts, water does not go back. The only way water can go back is when ATH is released. When ATH is released, what's alpha? What is the coordinators I should give you tests. Tests. Anatomy and physiology. What about nursing? No. What about nursing? I will also give you nursing.
By the grace of God.
Let's go to God. Don't make noise. Don't make noise, please. Don't make noise. Everybody will pass.
Amen. Amen.
Let's do a simple quiz.
Yes, sir.
All right. Well, let's continue.
Let's continue.
Don't make noise. Everybody, I'm going to medicine. Hello. All right. So I must say something.
Yes.
Okay. So 8 years, we go to what? The collecting dots and stimulate the V2 receptors. Right? In the collecting dots. When the V2 receptors are stimulated, what will happen? It will now make the collecting dot to become what? Permeable to water. And it will begin to reabsorb water. When once water is reabsorbed, what will happen? It will restore the water content of the body. From the kidney now. From the kidney. Do you understand? Kidney recruits urine. So when once it filters it from the blood, right? It filters urine from the blood. So when once water gets to the distal coagulated urine and goes beyond that, it becomes urine. Yes. So do you understand? Do you get it? Do you understand? Can I go on? Yes, thank you, yes, you are right. Now, the next one. Hello.
Okay.
What's the problem? Is that?
This components of organisms, can they be affected like the receptors, something affected?
Sorry, what you say?
These components of mechanisms, can they be affected?
The what?
The components, the receptors affect
They can what?
can they be affected?
Affected in terms of what?
Can anything deviate their...
Yes, now, of course. Now, please don't distract me. But you know, hello.
Hi.
See, where is that? In the hypothalamus. You understand? If the blood, if the electrolyte in the blood becomes what? High. Those four receptors will what? Detect it. Are you there? And when the right temperature what? Regulation. How does the body respond to an increase in temperature and a decrease in temperature? When there is an increase in body temperature, what happens? You know, in the skin, we have what we call thermoreceptors. Are you there? We have what we call receptors. These receptors will be any deviation in the body temperature. So for instance, if there is an increase in body temperature, the thermoreceptors will pick it. When they pick it, what will happen? They will send that information to what? To the brain. Are you there? They will send that information to the brain, particularly what? The hypothalamus. Are you there? The hypothalamus will send information via the spinal cord down to where? Down to where? To where? Number one, it can send that information to what? To the blood vessels. Right?
Yes.
Are you there? What does it do to the blood vessels? When there's an increase in body temperature, what will happen? It will dilate the blood vessels. When the blood vessels are dilated, what will happen? Heat will what? Will be what? Release from the blood. Are you there?
Yes, sir.
Are you there? The second thing is that, don't make noise now. Heat will be released from the blood pressure, and then that will now decrease the blood pressure. Do you understand? Are you there? When there's temperature, not blood pressure. Temperature. The next thing is what? It will go to the skin. Are you there? It will go to the skin. What does it do to the skin? It will stimulate the sweat glands. Are you there? It will stimulate the sweat what? Glands. When the sweat glands are stimulated, what will happen? It will result in the production of what? It will decrease the production of sweat. Right? Are you there? It will decrease the production of what? Sweat. You know, sweat usually releases what? Heat. You understand? So it will decrease the production of what? Sweat. Another thing is that it will go to the muscles, right? And prevent the contraction of the muscles. Are you there? Normally, when there is heat, the muscles will not contract, right? They will not be shivering. You know that shivering has the way of generating heat. Are you there? So it will prevent shivering. The muscles will not contract, the muscles will not shiver. And when you don't shiver, heat will not be what? Generated. So it will help to cool the what? The muscles. Are you there? Now, when there is decrease in temperature, will send information to the what? To the hypothalamus. The hypothalamus will send information to what? To the what? The blood pressure. The blood vessels. Then the what? Spinal cord. What will the information do to the blood vessels? It will bring about what? Vasoconstriction. When the blood vessels constrict, it moves away from the skin. Are you there? And conserves what? Heat. Are you there? It conserves what? Heat. And when heat is conserved, what will happen? It will increase the what? Body what? Temperature. You can't hear me? You cannot hear me? All right. I was talking about temperature regulation. Are you there? Can you hear me? I'm talking to them. I am sorry. Sorry, I was talking about temperature what? Regulation. Now, when there's an increase in temperature, right? An information, right? You know we have what we call thermoreceptors in the skin. The thermoreceptors will pick this information, right? And send information to the what? Hypothalamus. The hypothalamus will send an information via the spinal cord down to what? To the blood vessels, right? What does it do to the blood vessel? It brings about vasodilation, right? It dilates the blood vessels. When there is vasodilation, heat is what released from the what? Blood, from the blood. Are you there? Also, it goes to the what? The skin and prevents the production of what? It goes to the skin and prevents the production of sweat. Are you there? It does not stimulate the sweat. Sweat gland to produce more sweat. If sweat is not produced, then heat cannot be what? Lost. Are you there? Are you there? Also, apart from that, what else happened? Look at that. It goes to the muscles, right? And this time around, it does not stimulate what? The muscles to what? Shiver. Normally, when there is cold, the muscles will begin to what? Shiver, right? The muscles will not, you begin to shiver, the muscles begin to contract. Why? So that heat will be what? Generated. So it prevents shivering and prevents the contraction of what? The muscles, the bigger contraction of the muscles. So in order not to produce what? Heat. Are you there?
Yes, sir.
Are you there? Now when there is cold, right? When you are feeling cold, what will happen? The reverse is the case. Information from the thermoreceptors will be sent to the what? Hypothalamus. Hypothalamus will send information to the what? To the blood vessels. And when information goes to the blood vessels, what will happen? It will bring about vaso what? Vaso what? Vaso what? In cold. Yes, you are right.
Constriction.
It will bring about vaso what? Constriction. Are you there? When the blood vessels are constricted, it will what? Conserve what? Heat. Right? Not only that, it will also stimulate what? The sweat glands. Are you there? When these white lines are stimulated, what will happen? Are you there? What will happen? No. During cold, you will not sweat. Are you there? You will not sweat because if you sweat will bring about cooling. Are you there? So it will prevent the sweat glands from what? Producing what? Sweat. Are you there? The next thing is that it goes to the muscles and stimulates the muscles. Are you there?
Yes.
When it stimulates the muscles, what will happen? When you begin to have contraction, you begin to what? Shiver. When you shiver, what will happen? Shivering will generate what? Heat. Which will what? Restore the what? Temperature to what? Normal. Are you there? Alright. So let us go to positive feedback mechanism now. Positive feedback mechanism. Alright. So when we talk about positive feedback mechanism, right? In positive feedback mechanism, there's a change. Right? There's a change that brings about more change. Are you there? There's a change that brings about what? More what? Change. In order to what? Resolve a situation or a deviation. Are you there? For instance, a good example is during childbirth. You know what we call childbirth? We call it parturition. Are you there?
Yes.
During parturition, what happens? Now, when a lady wants to give birth, when a woman wants to give birth, right? Contraction will start, right? When contraction starts, what will happen? The contraction will push the baby towards the cervix. Is it not so?
Yes, sir.
When the baby gets to the cervix, when the head of the baby gets to the cervix, what will happen? It will stretch the wall of the cervix. Is it not so?
Yes, sir.
When the walls of the cervix is stretched, what will happen? It will stimulate receptors that are located around the wall of the cervix. When these receptors are stimulated, information will be sent to the what? To the what? To the hypothalamus. It will stimulate the hypothalamus. And then the hypothalamus will stimulate what? The pituitary gland. In this case, it will stimulate the anterior of the what? Posterior.
Anterior.
The anterior of the posterior. It will stimulate the posterior pituitary. When the posterior pituitary is stimulated, what will happen? It will result in the release of what? Oxytocin. Thank you. When oxytocin is released, it goes into the blood, right? And where does it go to? It goes to the what? The uterus, right? And bring about more contraction. More contraction of what? Of the what? Of the uterus. When there is more changes that now resolve the situation. Is it not so? That is number one. Number two is during milk downward reflex. Are you there? During what? Milk
left.
The class size is making me to shout. Can you see this?
Yes.
Big let down reflex. Are you there? Now, when a baby suckles the mother, right? When the baby suckles the what? Mother, the baby will stimulate what we call the myoepithelial cells, what? In the breast. Are you there? When these cells are stimulated, the cells will send a barrage of information to the hypothalamus, which sends an information to the what? The posterior pituitary to release oxytocin. Are you there? One of those, it releases oxytocin, and then it also sends an information to the anterior pituitary to release what? Prolactin. You're not hearing it, but I'm shouting now. Am I not shouting? I'm shouting. It's affecting my voice.
Can't kill yourself, sir.
Huh?
So continue.
Okay, let me stand here.
Yes, sir.
Let me stand in the middle. Alright. So now, like I was saying, that during milk let down reflex, right? When the baby suckles the mother, right? It stimulates what we call the myoepithelial cells. When the myoepithelial cells are stimulated, it sends right? To the brain. Is it also?
Yes, sir.
Particularly to the hypothalamus that stimulates what? That stimulates the what? The pituitary. The anterior and the posterior what? Pituitary. When they stimulate the anterior pituitary, what happens? It results in the production of prolactin. Are you there?
Yes.
Prolactin, what does it do? It goes to the breast and causes the production of more what? Milk. So that as the baby continues to suckle, more information will be sent towards to the brain to release more prolactin that will release what?
More milk.
Do you understand?
Yes, sir.
Secondly, it will stimulate the posterior pituitary. When the posterior pituitary is stimulated, it results in the release of what? Oxytocin. Oxytocin goes to the what? To the what? It goes to the breast, the myoepithelial cells, and bring about the contraction of the myoepithelial cells to release what? More of the milk. As the milk is being released into the mouth of the baby continues to suckle. Do you understand? And it continues to what? Stimulate the myoepithelial cells, which continues to generate more impulses and send these impulses to the hypothalamus. The hypothalamus sends information to what? The pituitary gland. The pituitary gland continues to produce what? Oxytocin and what? And prolactin. Do you understand?
Yes, sir.
Do you understand?
Yes, sir.
That is what two. The third example, the third and the last example I will give you is during hemostasis. Hemostasis. There's a difference between homeostasis and hemostasis. Hemostasis is the processes that are involved in what? Clot formation. Clots, blood clots. I will teach you that one.
Yes.
Are you there? I will teach you that one. It is the processes that are involved in the formation of what? Clots. When you bleed, right? When you bleed, your blood will form what? Clots and prevent bleeding from taking place.
Yes.
That process is called hemostasis. Hemostasis. Are you there? It is called what? Hemostasis. This process is driven by a positive feedback what? Mechanism. Are you there?
Yes,
The
sir.
process is driven by what? A positive feedback what?
Mechanism.
Now what happens? Now, when there is a cut in the blood vessel, right? When there is a cut in the blood vessel, the collagen fibers, right, is exposed. When the collagen fibers is exposed, what will happen? It will stimulate platelets. Are you there?
Yes, sir.
It will stimulate what? Platelets. When it stimulates platelets, platelets will release certain chemicals or substances, such as histamine, right? Are you there? And thromboxane A2, histamine, thromboxane A2, ATP. Are you there? Histamine. No, sorry, serotonin. Serotonin. Right? Thromboxane A2. All these will go and stimulate more platelets. When these platelets are stimulated, it will bring about the aggregation of platelets. Are you there? The aggregation of platelets will now form a clot. One platelet will begin to aggregate here when you have a cut. Are you there? Which will result in the formation of what? A clot. Are you there? Are you there? It will result in the formation of what? A clot. Are you there? Now, another thing that happens is that eventually this process will result in the formation of what we call prothrombin activator. Are you there? Prothrombin activator will result in the conversion of prothrombin to thrombin. Are you there?
Yes, sir.
Result in the conversion of prothrombin to what? Thrombin. Now, thrombin will result in the conversion of what? Fibrinogen to what? Fibrin. Are you there? And then this, the cut will be what? Closed or occluded. Are you there?
Yes, sir.
So that is that about homeostasis, feed-forward mechanism, positive feedback mechanism, negative feedback what? Mechanism.
How will I say this?
God. Okay, you have said it.
No, I've not saved it.
End it now.